Righty, 12, we're back. We are looking at some applications of the differentiation of some exponential functions here. Now that we can differentiate these things, well, we can do all sorts of things with normals and tangents and sketching and whatever else. These become fairly involved problems, so I'm going to have to split this into two videos. They'll both be reasonably long, I imagine. Nonetheless, let's get straight into it. These techniques that we're going to use, nothing new to this. Okay, the only new part is we're doing them with exponential functions. But all this stuff about tangents and normals and whatever else are all things that you've done before with other types of functions. So first of all, we have a curve here, and I've got a point. A is where x equals 1 on this curve here. So it's probably a good idea, first of all, to find the coordinates at that point. So let x equal 1, therefore y equals 2e to the 1 equals 2e. So therefore A is at 1, 2e. Okay, that's not the answer to anything so far, but nonetheless, that'll be a really important thing as we go through this. Find the equation of the tangent, because I'm going to need that. Y minus y1 equals m into x minus x1. There's my x1 and my y1. That's good, but I need the gradient, which is, of course, the differential at that point. So let's say function x equals 2e to the x, therefore function prime x, the differential of that is equal to 2e to the x. The magic of exponential functions. Now we're going to say let x equal 1, therefore my gradient is equal to 2e. Gradient's 2e. Now we can say y minus 2e, y minus y1 equals m2e into x minus x1 minus 1. We will expand this out and we will end up with something pretty tiny, I reckon. I'm going to say y equals, I'm going to bring that 2e over here in a moment. I'll get 2ex minus 2e plus 2e. Y equals 2ex. That is the equation of the tangent to that curve at point A. That's part A done. Wonderful. B. Show that it passes through the origin. Let x equals 0 for y equals 2e times 0 equals 0. Therefore, passes through 0, 0. As rushed as I am doing this, I'm still not writing THRU. Right. Passes through the origin. Right. Easy enough. That's a nice one. C. Find the equation of the normal of the point A. Well, I've got that point there. That's helpful. I need a gradient here for the normal, and the gradient of the normal is going to be negative reciprocal of the gradient of the tangent. So I'm going to say if m1 is perpendicular to m2, then m2 is equal to negative 1 over m1 equals, what was it? Negative 1 over 2e. Therefore, y minus 2e equals negative 1 over 2e into x minus 1. Multiply throughout by 2e and I get 2ey minus 4e squared equals negative x plus 1. Rearrange things a little bit and I get 2ey plus x equals 4e squared plus 1. Righto, that'll do us. I could say x plus, that's fine. That's fine there. That is the equation of the normal. Okay, that's the equation of the normal. Great. Now, find the point B where this crosses the x-axis. So for part D, where does it cross the x-axis? It crosses the x-axis when y equals 0. Let y equal 0. Therefore, 0 plus x equals 4e squared plus 1. Geez, that was nice. That's part D done. That's where it crosses. Oh, so I should say, therefore, let's say the normal crosses x, oops, axis at, because really I've only given one of the points, haven't I? At 4e squared plus 1, 0. Yep. Okay. That's D, and finally E. Find the area of AOB. Now, let's have a look. We need a sketch. You just about always need a sketch. My exponential function is going to look like this. Right, and it's going to look something like this. X and Y. Now, we knew that it crossed here at 2. I don't know how important that's going to be. I know that A is at 1, 2E, which we'll call this A. That makes that 2E. And that point there, 1. I know that the tangent passes through the origin like that. Right, so that's O. O is for the origin. There's A, AO, and B is at right angles to that. Yep, that's B there, and that is at 4E squared plus 1. That's where that point there is. And that's a right angle, which is not actually going to make that much of a difference, because the way we're going to solve this, I'm going to use this as the base, and this is the height. Right, here is a triangle with a base of 4e squared plus 1 and a height of 2e. Area equals half the base times the height, perpendicular height. Yep, none of this half AB sine C business or anything complicated like that. Nope, no distance formula. You could do that, but boy, you would be making your life hard where I have a perpendicular height and a base here. So my area equals half times my base. 4e squared plus 1 times 2e. Of course, the half and 2 wipe out pretty well, and I get e outside of 4e squared plus 1 units, square units. How about that? Righto, I think it's quite enough for the first video. There's quite a lot going on there, but you'll see all of those techniques are things you've done before. There's just a little bit of differentiation of exponential functions, and frankly, not even that much of it. Okay? Good work. Keep an eye out for the next video.